Hello, dear great students. We are back again with another video lesson. Hope you are all doing well. After we finish chapter 2, today's lesson, we are explaining chapter 3, section 1 about the fluids and buoyant force. If you remember, in chapter 2, section 1, we studied about the phase of matter. If you remember, we had 4 states of matter: solid, liquid, gas, and plasma. Okay. So in this chapter, in this section, section 1 in chapter 3, we are focusing on the fluids. Okay, fluids and buoyant force. At first, I would like to define the fluid. What is fluid? A non-solid state of matter. What is fluid? A non-solid state of matter in which the atoms or molecules are free to move past each other, as in a gas or liquid. Okay, so a fluid, it means that like maybe gas or liquid. Okay, it is a non-solid state of matter, like maybe liquid or gas. Okay, so we have some notes about the fluids. Matter is normally classified as being in one of the 3 stages: liquid, solid, or gases. So the figure 1.1, as you can see here, we have 2 figures, A and B. Is a photo of a liquid. The figure A is liquid and figure B is gas. Both of them we can say fluids, okay, because fluids is a non-solid. What do you mean by non-solid? Maybe liquid, maybe gas. Figure 1.1b shows an example of gas. So one property they have in common is ability to flow. Ability to what? To flow and alter their shape in the process. What are the similarities, or what are the common between the fluids, like between gas and liquid? Both of them, they have ability to flow, and both of them, they can change or alter their shapes, because both gas and liquid, they don't have a definite shape. Solid objects are not considered to be a fluid. Why solid object cannot be considered to be a fluid? Because because they cannot flow and therefore have a definite shape. Okay, solid cannot flow and has a definite shape. So that is why the solid state cannot be considered to be a fluid. What characteristics do gases and liquids have in common, or what are the similarity between gas and liquid? As I mentioned before, the ability to flow. Both of them, they have ability to flow and alter or change their shapes. Why are solid objects not regarded, not considered to be a fluid? Because they cannot flow and their shape is definite and cannot alter or change the shapes. So the difference between liquid and gas we studied in chapter 2, section 1. Liquids have definite shape, definite volume. Gas do not. Liquids have definite shape, but gas, they don't have a definite shape. Even though both gases and liquids are fluids, there is differences between them. There is some differences between them, and we have difference between between gas and liquid, and at the same time we have the similarities. The similarities we studied. The similarities between gas and liquid, both of them, they can flow, ability to flow and alter or change their shapes. At the same time, we have a difference between liquid and gases. Okay. So the difference between gas and liquid, as you know, both of them, they have indefinite shape, okay? But the liquid has definite volume, but not definite shape. Gas has no definite volume, no definite shape, neither, okay? Okay, liquids have definite volume, gas do not, even though, okay, we studied, even though the gases and liquids are fluids, there is a difference between them. Liquid has definite volume and gas doesn't, okay? Liquid has definite volume, but gas has no definite volume. Liquids, like solids, have definite volume, but unlike solid, they don't have a definite shape. Gas have neither definite volume nor definite shape. Density and buoyant force. Another topic in this section, guys, is about the buoyant force. But before explaining about the buoyant force, I would like to tell you something about the density or the mass density. What is mass density? The concentration of the matter of an object, measure it as the mass per unit volume of a substance. So density depend on what mass of the object and the volume of the object. According to this relation, density is equal to what? Mass per volume. The relation between density and mass is directly proportional at constant volume. And the relation between density and volume is inversely proportional at constant mass. More mass is a small volume has more density, but less mass in a large volume has less density. So when does the object has more density? When the all mass is concentrated in a small volume. More mass in a small volume has more density. So that is why its definition is the concentration of matter of an object measured as the mass per unit volume of a substance. So the SI unit of density, it is SI unit, guys look, the SI unit of density, according it is equation mass per volume, kilogram per meter cube. This is SI unit of density, but sometimes in some questions, instead of kilogram per meter cube, we can use gram per centimeter cube. Okay, so the density has 2 units, but the kilogram per meter cube is the SI unit of density. When the word density is used to describe a fluid, what is really being measured is the fluid's mass density. Mass density is the mass per unit of volume. So measure it. Its symbol is rho, a Greek letter. It means that density. So in this table, we have some substances with it is density, like the density of hydrogen, 0.0899 kilogram per meter cube. So the density of air is constant, 1.29 kilogram per meter cube. So the density of the fresh water is 1,000 kilogram per meter cube. So for the student, you have to memorize the density of a fresh water is equal to 1,000 kilogram per meter cube. Sometimes it's not given in the question. So that is why you have to keep in your mind and you have to memorize the density of fresh water is equal to 1,000 kilogram per meter cube. The SI unit of mass density, kilogram per meter cube, as I mentioned, solid and liquid tends to be almost incompressible, meaning that their density changes very little with the pressure. Solids and liquids are approximately independent of the pressure because they are incompressible. Gases, on the other hand, are compressible and can compress easily because the particles is far away from each other, so they can have a densities over a wide range of the values. Thus, there is not a standard density of the gas as there is for the solids and liquids. Like there is no standard density of the gas because the particles are far away from each other, and this particle is they can have a density over a wide range of the values. Okay, guys, buoyant force. What is buoyant force? Buoyant forces can keep object afloat. So this is very important, and we are not in our daily life, so we can't see sometimes some objects float in the surface of water. Sometimes the object sinks in the water. So what is the reason? Now I'm going to explain in details. What is buoyant force? The buoyant force is a force measured in Newton because force is a vector quantity. What do you mean by vector quantity? It means that it has both magnitude and direction. Buoyant force is a force measured in Newton. It is a vector quantity. It means that it has a direction. The direction of the buoyant force is opposite direction of the gravitational force. Opposite direction of gravitational force, it means that the direction of the buoyant force is upward always. Why? Because the direction of the gravity is always downward directed toward the center of Earth, and the buoyant force acts in opposite direction of the gravitational force, which is always directed upward. The upward force, always upward? Yes, always upward. The upward force exerted by what? So the source of the buoyant force is fluid or liquid. The force exerted by what? By liquid or by gas on an object immersed in or floating on the liquid. In both cases, it doesn't matter. The floating object and the immersed object. In both cases, the buoyant force acts on the object. Its direction is upward. Okay, so the buoyant force is an upward force that exerted by fluid, maybe gas or liquids. Okay, so it doesn't matter the object sink or immersed. In both cases, there is a buoyant force acting on the object. Why things feel lighter underwater than they do in air? Why the thing is lighter under the water than they do in the air? Because of the buoyant force. Because in the fluid, like in the water, there is another force acting on the object in opposite direction of the gravitational force. As you know, the gravitational force acts in all objects down, or pulls down everything toward the earth. Okay, but the buoyant force acts in opposite direction of the gravitational force, so that is why the objects feel lighter underwater than they do in the air. So the reason is that the fluid exerts an upward force on objects that are partially or completely submerged in it. This force is called a buoyant force. This upward force is called what? A buoyant force. Assume that we have a container of water, okay? Like, for example, this container is full of water, and the object, like for example, if you put an object, okay, this is floating object, guys. The object floats at the surface of the water, okay? What is the reason why the object floats at the surface of the water? Because of the density and because of the buoyant force. As you can see here, the direction of the gravitational force is always downward. What is this? This is gravitational force. Gravitational force pulls everything down. Another force acting on the object is called the buoyant force. It's acting upward. Okay? This upward force is called what? Buoyant force. Buoyant force is upward force, yes. Always acting in opposite direction of Fg, yes. Measure it in Newton, yes. Okay? So exerted by fluids, yes. The buoyant force exerted by what? By fluids. So we have some important tips and notes about the buoyant force. Listen carefully, please. Things feel lighter underwater than they do in the air because of the buoyant force. Fluids exert an upward force on objects that are partially or completely submerged in what? In it, or in water. This upward force is called what? Buoyant force. So the symbol of buoyant force, F sub B. Buoyant force acts in a direction opposite. Opposite what? The force of the gravity. Always in opposite direction. So the angle between FB and FG is 180. The net force acting on an object submerged in a fluid, such as water, is smaller than the object's weight. The net force for the submerged object, like for example, this object float. This is floating object. For floating object at the surface of the water, FB bigger than FG. For floating object, like for example, when the object located at the surface of the water, in that case, buoyant force is bigger than the gravitational force, okay? So for submerged object, submerged, it means that sinking object, okay? Sink object. Like for example, if you have a container of water and the object located at the bottom of the container. So in this case, the object submerged or immersed in the water. Okay. So in this case, guys, be careful. The direction of the gravitational force is always downward, and the direction of the buoyant, do we have buoyant force? Yeah, we have. Still in both cases we have a buoyant force, but here the buoyant force is acting upward. Okay, in both cases the buoyant force is upward, but in this case FB is bigger than FG. That is why the object floats at the surface of the water. But in this case FG is bigger than FB. That is why the object sinks, or the object submerged in this container. So for the submerged object, which one is bigger? FG bigger than FB. Okay. So when does buoyant force bigger than gravitational force? When the object floats at the surface of the water. When does gravitational force is bigger than buoyant force? When the object sinks, or when the object submerged in the container. So in this case, the FG overcome buoyant force. But here, the buoyant force overcome the gravitational force. That is why the object, and because of the buoyant force, the object floats at the surface of the water. Okay, guys, another case, like for example, for the suspending object in the water, like if the object suspended in the middle of the container, not at the bottom of the container, not at the surface of the container. In this case, guys, listen carefully. This is very important. When the object suspend in the water, okay? Here the object suspended, okay? For the suspended object in the water, in this case, gravitational force always downward, buoyant force always downward, because the object does not locate it at the surface of the water and does not sink at the bottom of the container. So that is why Fg is equal to Fb. Okay? For the suspended object, when the part of the object it's still in the water, and at the same time the object does not sink and the object is not located at the surface of the water, so that is why the gravitational force is equal to buoyant force. And the net force between these two forces is equal to what? Net force is equal to 0. When does net force become 0 between buoyant force and gravitational force? When the object suspends at the middle of the water. Okay? When the part of the object sinks in the water. But when the entire object located at the surface of the water, in this case, buoyant force, guys, look, buoyant force is bigger than the gravitational force. Why? Because the entire object located at the surface of the water. No part of the object sinks in the water. Okay? So in this case, net force becomes what? Net force becomes positive. Net force becomes what? Net force becomes positive. Why? Because buoyant force is positive. Gravitational force is negative. Which one bigger? Positive or negative for the floating object? The positive. Buoyant force is bigger than gravitational force. That is why net force becomes positive. When does net force between buoyant force and gravitational force becomes positive? For floating object. When the object floats at the surface of the water. Okay? When does a gravitational force, the net force becomes negative? When does net force becomes negative? When gravitational force bigger than buoyant force. In the case, like for example, when the entire object submerged at the bottom of the container, in this case, the net force becomes negative. Why? Because Fg overcome Fb. As a result, the net force becomes positive. Okay? Net force like no object submerged in a fluid such as weight is smaller than the object's weight. The object appears to weigh less in the water than it does in the air. We studied. The weight of an object immersed in a fluid is the object's apparent weight. The weight of the object that immersed or floating in the water is called what? Apparent weight. What is apparent weight? Like for example, this is the object in the air. Assume that Fg object in air is equal to 100 Newton. What is this? This is Fg object in the air. So the Fg object in the air is always bigger than Fg object in the fluid. Okay? After we put the object into the water, okay? So in this case, the apparent weight, Fg object in the fluid, Fg object in what? Should be less or more than the Fg object in air? Less. Why? Because the upward force exerted on the object, and so that is why the objects feel lighter in the water than they do in the air. Here in what? In air. Here inside the water. Okay? So for maybe Fg, sorry, this is just assume, okay? Let's say the gravitational in a fluid should be less than 80. It's up to you. 80, like for example, 80 newtons. This is just for example, guys, this value, okay? It should be less than 180. Fg object in fluid sometimes is called what? Apparent weight. It's called what? Apparent weight. What do you mean by apparent weight? Fg object in fluid. And sometimes it's called F net. The Fg object in the fluid sometimes is called the net force. Okay? And sometimes we can say apparent weight. What do you mean by apparent weight? Fg object in fluid or the net force acting on the object. Archimedes principle. What is Archimedes principle? Archimedes can be stated as follows. Any object completely or partially submerged in the water. Any object completely or partially submerged in a fluid. It doesn't matter which type of the fluids, like water, juice, or anything, or like air, experience an upward force. For any object partially or completely submerged in a fluid, experiences an upward buoyant force. Upward what? Buoyant force. This upward buoyant force, this amount of buoyant force Fb, is equal in magnitude to the weight of the fluid displaced by the object. Like for example in this figure. In figure A, a brick is being lowered into a container of water. Figure A. Nothing happens. So there is a spigot here, there is a small hole here. After we, like for example, after the brick is putting into the water is displaced by this hole, okay? So the displaced water is located into this small container. In figure B, the brick displaces water, causing the water to flow into a smaller container. This is a smaller container. Now we have some water in the smaller container. This water is results from the like when we put down the brick, and on this object it goes to the water level increasing and flowing into this small spigot or hole. The brick is completely submerged in figure C. The volume of the displaced water is equal to the volume of the brick. So that, and we can say the buoyant force is equal to the same amount of the Fg object displaced by the water. For example, look at this figure, guys. So when the object is putting into this water, okay, when the object submerged in the water, some of the water is displaced by this container and it goes to this small container. Now, do we have buoyant force here? Yes. After we putting the object into the fluid, this fluid exerts an upward buoyant force. Assume that the buoyant force, okay, for example, buoyant force is equal to 20 Newton. Okay? And the gravitational force also exerted by the object downward. So the amount of the buoyant force when submerged into this fluid is equal to the same amount of the gravitational force displaced by the water. What is this? This is Fg displaced by the water, okay? Fg displaced of the water is equal to the same magnitude of buoyant force. Okay, guys, once again, the Archimedes principle, it's very important. Listen carefully. The definition of Archimedes principle, or Archimedes principle, stated that any object completely or partially submerged in the water experiences an upward buoyant force. This buoyant force of the object that experiences or exerted by the fluid is equal to what? Is equal to the gravitational force of displaced water. The gravitational force for this water is equal to the same magnitude of what? Buoyant force. This is Archimedes principle. For the submerged object, Fe buoyant or buoyant force for the submerged object, buoyant force is equal to what? Fg. Which Fg? Fg object in air? Fg object in fluid? No. Fg displaced fluid. Fg displaced fluid. Fg displaced fluid is equal to buoyant force according Archimedes principle. For submerged object, Fg is always bigger than Fb, and net force is not equal to 0. Downward net force is negative. Net force becomes what? Becomes negative. So, guys, we have some equations to determine the value of buoyant force and Fg object in air. The object is density. To determine the magnitude of the buoyant force, if it's not given, Fb is equal to what? Is equal to Fg object in air minus Fg object in fluid. Fg object in air minus Fg object in a fluid. In this equation, you can determine what? Buoyant force. How can you determine the buoyant force? F buoyant force is equal to what? Fg object in air before putting into the fluids minus Fg object in fluid after we put the object into the fluids. Okay, Fg in air minus Fg in fluid. In this equation, you can determine the magnitude of buoyant force. Another equation, guys. This is for, guys, this is for submerged object. Listen carefully. For submerged object. For what? For submerged object. For submerged object, like for example, when the object is located at the bottom of the container, Fg downward, Fb upward, so Fg bigger than Fb, and net force is equal to negative, not equal to 0. Net force is what? Negative. For the submerged object, net force is negative, always. Okay? How can you determine the buoyant force for the submerged object? For the submerged object, buoyant force is equal to Fg object in air minus Fg object in fluids. This equation is very important to determine the buoyant force. The second equation, Fg object in air divided by what? By buoyant force is equal to object's density divided by fluid density. The second equation can be used to determine Fg object in air and object's density or fluid density. If you rearrange this equation to determine the object's density, what do you mean by rho naught? This is object's density. What is this? Object's density. And this is fluid density. To determine the object's density, cross product, it becomes like this. Fg object in air times fluid density divided by buoyant force. By using this equation, you can determine what? Object's density. So how about the fluid density? How can you rearrange this equation to determine the fluid density? Guys, look. If you want to find the fluid density is equal to what? You can rearrange by cross multiplication between these two fractions. Buoyant force times object's density. Buoyant force times object's density over what? Fg object in air. If Fg object in the air is not given, you can determine if the buoyant force is not given, you can use this relation to find buoyant force. After that, replace into this equation. Look at the sample problem. Look at this sample problem, guys. Sample problem 3A. Sample problem 3A. Sample problem 3A, guys, look. A bargain hunter purchases a gold crown at a flea market. After she gets home, she hangs the crown from a scale and finds its weight to be 7.84 Newton before submerging into the water, into a fluid. So she hangs the crown in the air. So she measured the crown in the air. So Fg crown object in air is equal to what? 7.84 Newton. What is this 7.84 Newton? This is the crown's weight in the air. What do you mean by weight? Fg. Fg in air is equal to what? 7 in air. As you can see in this figure. The gravitational force of the crown in the air is 7.84 Newton. She then weights the crown while it's immersed. Immersed in what? Immersed in water. So she finds, she then weights the crown while it's immersed in the water. Fg object in fluid or in water. What is the time of the fluid? Water, okay, is equal to what? After submerging in the water, the object's weight decreased. Why? Because according to buoyant force, the objects feel lighter under the fluids, under the water, than they do in the air. If the object's weight in the air is 7.84, how about the object's weight in the fluid? The object's weight in the fluid must be less than the Fg object in the air. Fg object in water is equal to 6.86 Newton. Is the crown made of a pure gold? So the density of the fresh water is constant, is equal to 1000 kilogram per meter cube. The question asks us, the crown made of a pure gold, is this crown is a pure gold? Is a good gold? It means that the object's density is unknown. But guys, I will give you, and your teacher must be give you the amount of the object is like the amount of the gold's density. The actual density of gold, which is object's density, is equal to like 19, as you can see here in this table. Don't memorize the density of the gold. It should be given in the question. 19.3. 19.3 times 10 power 3 kilogram per meter cube. Now, I'm going to find the object's density, the density of this crown. If the object's density is equal to this number, we can say this crown is a pure gold, is a very good gold. Okay? But if the object's density, if I, like for example, if I find another value less than this value or more than this value, we cannot say this gold is a pure gold. Okay, so we have to compare the final result of the object's density that we find here, comparing with what? With the real value of the gold's density. If I get the same number, it means that this crown is very good crown, a very pure crown. But if I go the less than this number, we cannot say this is a pure crown. Guys, now what is unknown? The object's density. How can we determine the object's density? The object's density, look. Which equation can be used to determine the object's density? This one. Object's density is equal to Fg object in air times fluid density divided by buoyant force. Look. Object's density is equal to what? Fg object in air times the fluid density. What is the type of the fluid here? Is water. The type of the fluid is what? Is water. The density of the water is divided by what? Buoyant force. Guys, do we have Fg object in air? Yes. Do we have the density of water, fresh water? Yes. It was not given, but you have to know. Okay? So you have to keep in your mind that the density of the fresh water is 1000 kilogram per meter cube. Do we have buoyant force? No. We don't have buoyant force, guys, in the given values. Without buoyant force, you cannot determine the value of the object's density, the density of the gold. So what can we do in this case? We have to think about how can you determine the buoyant force. As I mentioned here, if the buoyant force is not given in the question, for the submerged object especially, buoyant force is equal to what? Fg object in air minus Fg object in fluid. Do we have Fg object in air? Yes. Do we have Fg object in fluid? Yes. Buoyant force, guys, look. Buoyant force is equal to what? Fg object in air minus Fg object in fluid. Fg object in air 7.84. Fg object in fluid 6.86. Buoyant force is equal to what? Is equal to 0.92 newtons. In this way, you can determine the buoyant force. So without buoyant force, we cannot solve the question, because to determine the object's density, we need the buoyant force. Okay? 7.84 minus 6.86 is equal to 0.98. Sorry, 98.
0.98. The buoyant force 0.98 Newton. Okay. Now, can we replace into this equation? Yes. To determine what? The object's density. Look. Object density is equal to, do we have FG object in area? 7.84. Do we have the density of the water? Yes. Thousands. Divided by buoyant force. Do we have buoyant force? No, we didn't have. But we found it. 0.98. 0.98. Object density is equal to what? Times 1000 is equal to 7,810 divided by 0.98, which is equal to 8, approximately 8 times 10 power 3 kilogram per meter cube. So the density of this crown is equal to 8 times 10 power 3. Comparing with the real density of the gold. The real density of gold is equal to 19.3 times 10 power 3 kilogram per meter cube. Is this two numbers close to each other? No. Is this two numbers equal to each other? No. So that is why we cannot say this crown is made of a pure gold. This crown is not the pure gold. Okay? So this crown is not the pure gold because the density of this crown is equal to 8 times 10 power 3, but the real density of the gold, of the pure gold, it should be 19.3. So that is why the crown cannot be a pure gold. The final answer is 8 times 10 power 3 kilogram per meter cube. Question 1. But before solving question 1, let's go back to the buoyant force for the submerged object. We have some important questions. Both direction and the magnet of the net force depend on the difference between the density of the object and the density of the fluid in which it's immersed. If the object's density is greater than the fluid density, if the object's density bigger than the fluid density, what happens to the object? The net force is negative. Net force becomes what? Negative. And the object sinks. Okay, when does the object sink? If the object's density bigger than the fluid density. So the net force becomes what? Becomes negative. And Fg bigger than Fb. For the first case, for the submerged object, if object's density bigger than fluid density, net force becomes negative, and Fg bigger than Fb, so the object submerges or sinks. If the object's density less than the fluid density, the net force is positive. If the object's density less than the fluid density, the net force becomes what? Becomes positive, and the object floats at the surface of the water. So Fb bigger than Fg. The situation is completely different, guys. Okay? The last case, this is very important. Pay attention, please. In the last case, like if the object, if the density are the same, the object hangs suspended under the water. Like for example, if the object's density is equal to the fluid density, net force is equal to 0. What happened to the net force? Becomes 0. And the object suspend, not submerged, not float at the surface of the water. Okay? But it's considered to be a fluid object. Okay? The suspended object also considered to be a fluid object. But in this case, buoyant force is equal to gravitational force. So these three notes are very important. Pay close attention. When object density bigger than fluid density, net force becomes negative and the object sinks, and Fg bigger than Fb. But when the object density less than the fluid density, net force becomes positive and the object floats. FB bigger than FG, like, but for example, when the object's density equal to fluid density, net force 0, and FB is equal to FG. When does the object submerge? If the object density greater than the fluid density, as you can see in this figure. When does the object float? If the object is density less than the fluid density and the net force is positive. When does the object hang suspended in the water? If the densities are the same. Okay. Question 1 in practice 3A. Practice 3A. Question 1. The question says a piece of metal weighs 15 Newton in air. FG object in air is equal to 15 Newton. Okay. And 36 Newton in water. FG in water, in fluid, is equal to 36 Newton. Okay. And 41 Newton in unknown liquid. FG in unknown is equal to 41 Newton in unknown liquid. Find the densities of the following. A, for the metal. B, the object's density. Metal, it means that object density. And for the unknown liquid. Unknown liquid, the density of the fluid is unknown. Okay, guys, in this case we have two container of the fluids. Okay, this is unknown liquid. We don't know what is the type of the liquid, but in the first container we have water. Okay, what we have a water of the container, but in the second container we don't know what is the type of the liquid. We have two liquids. One liquid is known as water and another liquid is unknown liquid. Okay, so this is the object's density. It is Fg in air. At first in air is equal to 15 Newton in air. After submerged in the fluid, it is Fg becomes what? Fg in water is equal to 36 Newton. After that, submerged into this liquid, unknown liquid, it is Fg is equal to 41 Newton. How many liquids do we have? Two different liquids, guys. So each liquid exerts an upward buoyant force. The buoyant force for this unknown liquid is completely different with the buoyant force of the water, because each of them has its weight in the liquid. Like for example, for branch A, how can you determine the object's density? To determine object's density, guys, how can you determine object's density? Object density is equal to Fg object in air times the density of the water. Why? Because at first we have to find the object's density in the water. Okay, in what? In the water. Fg object in air multiplied by the density of the water divided by what? Divided by the buoyant force. Do we have buoyant force? No. We don't have buoyant force. How can you determine the buoyant force? Buoyant force is equal to what? Fg object in air minus Fg object in water. Buoyant force is equal to 50 minus 36 is equal to 14 Newton in the water. The buoyant force in water is equal to what? Is equal to 14 Newton. Replace into this equation to determine the object's density. Fg object, the metal. Fg object in air, 50 times the density of the water is constant, thousands, divided by what? 14. Object density is equal to what? By calculator is equal to 50,000 divided by 14, which is equal to 3,571 kilogram per meter cube. This is the object's density. Okay, in this way you can determine the object's density. The second unknown, the density of the fluid, the density of unknown liquid. Guys, without the density of the object we cannot determine the density of the unknown liquid. Okay, how can you determine the density of the unknown liquid? Look, The density of unknown liquid. Branch B, the density of unknown liquid or fluid is unknown. Which equation can be used? You can use this equation to find or to determine the fluid density. Is equal to what? F buoyant times the object's density divided by what? Fg object in air. Fg object in what? In air. Fluid density, the density of unknown liquid. Do we have buoyant force? No. We don't have buoyant force for unknown liquid. The buoyant force for unknown liquid is equal to Fg in air minus Fg in liquid. In the second case, the buoyant force for the unknown liquid, Fg object in air was given 50 minus Fg object in unknown liquid is equal to what? 41. Minus 41. Buoyant force is equal to what? Is equal to 9 Newton. What is the difference between these two buoyant force? Guys, how many liquids do we have? We have two different liquids. So that is why we have to find two buoyant forces. The buoyant force for the water and the buoyant force for the unknown liquid. The buoyant force for the water is equal to 14 and the buoyant force for the unknown liquid is equal to 9 Newton. But buoyant force we didn't have, but we found 9. Density of the object also we didn't have, but we found 9 times 3,571 divided by Fg object in air is equal to 50. So you can calculate by your calculator, which is equal to 9 times 3,571 divided by 50 is equal to 642.8 kilogram per meter cube. This is the density of the unknown liquids. In this way, you can determine the density of the unknown liquids. Guys, in the second part for the floating object, so this is for the submerged object, okay? We solved with sample problem 3A and the practice 3A question 1. Now, for floating object, guys, or suspending object in the water. For floating object, use this relation. For floating object or suspended in the water, Fb is equal to what? Fg. If the buoyant force is not given, the buoyant force is equal to m times g and m naught times g. What do you mean by m naught? The object's density, okay? And if the mass is not given of the liquid, mass is equal to what? Density times volume, and gravity is remain, okay? So m naught times g. These relations can be used to determine sometimes the object is the object's density, and the mass sometimes can be used for this object that floating in the fluids. Okay, guys. In this case, buoyant force is equal to gravitational force when the object is suspending in the water. Okay, so for floating object, guys, Fb is equal to Fg. Okay, so look at this question. 2.8 kilogram rectangular air matrix. The mass of the air matrix, assume that this is a pond of water. Okay, so this is the air matrix. Okay, the air matrix is in the water and it's floating or suspending. The mass of air matrix is equal to what? Mm. What do you mean by m sub m? The mass of the air matrix is equal to 2.8 kilogram. This is question 2. 2 meter long. The length of the air matrix is 2 meter long, and its width is 0.1 meter. Its width is 0.1 meter, and its thickness is like its width is 0.5 meter. So its thickness is 0.1 meter. The width of the air matrix is 0.5 meter, and the thickness, which is height, is equal to 0.1 meter. The length of the air mattress is 2 meter, and its weight is 0.5 meter. So its thickness, which is height, is 0.1 meter. What mass can it support in water before sinking? What do you mean by before sinking? Before sinking, it means that float or suspend. Before sinking, it means that the mattress does not sink or does not immerse, but we have to put an object here before sinking. M support, the supported mass is unknown. What is unknown? The second mass. Because in this question, how many masses do we have? We have two masses. The mass of the air mattress and the mass of supported mass. Can it support in water before sinking? We have two masses, guys, M1 and M2, MM and MS. Because the object does not submerge, we have to use this relation. FB is equal to FG. Do we have buoyant force? No. And instead of buoyant force, you have to write down mg and m0 g. Okay? These two gravity cancel each other. Okay? So, do we have mass of the fluid? No. But instead of mass, we can write down rho v is equal to how many masses do we have? M2 masses. The mass of air mattress plus the supported mass. Okay, do we have the density of water? Yes, 1000. Do we have volume? No. And instead of volume, we have length times width times height is equal to mass of air mattress 2.8 plus the unknown mass. The unknown mass is unknown. Okay, so how can you determine the mass of the supported object? Okay. Do we have length? Yes. Guys, look. We don't have volume, but instead of volume, we have length times width times height. Bring down the thousands. L, 2 meter. Width, 0.5. Height, 0.1. 2.8, the mass of air mattress, and the supported mass unknown. Okay, 2 times 0.5, 1. 1 times 0.1, 0.1. 0.1 times 1000 is equal to 100. 2.8 plus the supported mass. Move this 2.8 to the other side, it becomes negative. The supported mass is equal to 100 minus 2.8, which is equal to 98. This is 97.2 kilogram. Okay, how can you determine the mass of the supported by the air mattress? You can use this relation to determine the supported mass, which is equal to 97.2 kilogram. Sorry. Okay, so in this way you can find the unknown mass. Question 3, a ferry boat is 4 meter width. Question 3, a ferry boat is 4 meter width, 4 meter length, 6 meter, and when the truck pulls onto it, the boat sinks 4 centimeter. This sinks, guys, this is height. The thickness and the sink is equal to 4 centimeter, which is equal to 0.04 meter. Why? Because it is not allowed solving question with the centimeter. You have to convert to the SI unit, which is meter. In the water, what is the type of the fluid? Water. What the density of the water is equal to thousands kilogram per meter cube. What is the weight of the truck? The FG of the truck is unknown. Because the object does not submerge, we don't have FG object in air, FG object in fluid, and the object is floating, suspending. So that is why FB is equal to FG, or FG is equal to FB. Okay? Do we have FG? No. FB is equal to density times volume times gravity. Look, guys. It's very easy. Do we have the density? Yes. but we don't have volume. And instead of volume, we have L, width, length, and height times gravity. Fg is equal to what? Density of the water is equal to 1,000. Length 6 meter, width 4 meter, and the height, the boat, it sinks 4 centimeter. 0.04 times 9.81. Fg of the truck is equal to, you can calculate by your calculator, 6 times 4 times 0.04 times 1000 times 9.81. I got 9,417.6 Newton. This is the weight of the truck. Okay, so I'm running out of time, guys. Thank you for listening. Hope you get benefited from my lesson. Inshallah, in the next lesson we are continuing explaining chapter 3, physics for grade 10 students. Have a good time. Keep up your best doing.